Dear colleagues, good to see you at our workshop. This presentation devoted to digital resilience of Ukrainians and Ukraine in the energy crisis caused by massive missile strikes. Digital transformation is a process of sustainable development of a digital society whose economy based on information technologies. The semantic field of digital transformation includes such concepts as the digital economy, digital skills, digital rights, e-government, digital innovations, and much more. The digital component of existence acquires a significant value and becomes an object of attack. And the ability to resist an impact on the digital component of our being is known as digital resilience. Digital resilience has dual nature. It characterizes how successfully and constructively one overcomes challenges and adapts to changes using digital technologies. And also digital resilience includes resilience in digital environment, how successfully one is able to achieve aims effectively using various info communication systems. Digital resilience can be a property of an individuals, communities, businesses, societies, and the state. It is subject to analysis, measurement, and improvement, and much attention is spent to resilience of cyber systems, which are tightly related to power energy system. The experience of Ukraine is extremely valuable for the study of digital resilience. Ukraine was among the leaders of digital transformation before the large-scale Russian invasion. Missile attacks on the main facilities of the power industry lead to wide power outages. In December of 2022, multi-day outages took place. It is predicted that next winter will not be easier for Ukraine. Each business and each household must constantly review their survival options with new impacts on power grids. We must be resilient. In our opinion, science should contribute to the development of mechanisms of absorption of negative impact, adaptation and evolution of information and communication systems. This requires the collection, analysis and systematization of existing experience. We propose to define a digital ecosystem of digital subscribers, their digital needs, and digital means or digital tools, which can be used by digital subscribers to achieve their digital needs. While digital needs can be represented by remote working, electronic payments, distance learning, e-health, state services like electronic registry access, and very important need of electronic socializing, digital tools are a very vast number of information and communication infosystems which provide the ability to achieve those needs. I think there is no need to provide obvious examples of such info communication systems. To increase digital resilience to threats related to major power outages, the following tasks must be solved. To investigate most sensitive digital needs and digital subscribers, to analyze cyber threats that large-scale power outages pose and how they affect the digital needs, to analyze existing and available network architectures, types of electronic communications, data transmission systems, topologies, and determine how resilient they are to high-impact events in power grids. And finally, to find the most effective combination of digital tools which subscribers can use to satisfy their digital needs. Those three sets, digital subscribers, digital needs, and digital tools, form a variety of tuples of three elements each, based on existing and available combinations. Let there exist a heterogeneous set D which includes all the three sets of digital subscribers, digital needs, and digital tools. Then let's T is a system of elements of this set, which includes all possible digital ecosystems, namely all possible communications and combinations of those elements, unions, and intersections of these sets. Then T corresponds to the definition of topology on the set D, and that couple T and D corresponds to definition of topological space. Individual elements of the topology represent network structures that can be researched using graph theory, complex network theory, and topological space theory to develop models and methods to enhance digital resilience. To explain the way, let's look inside those structures, and we will see the key role of information and communication systems, their diversity, and also the diversity of their vulnerabilities to energy problems. Despite great success of air defense of Ukraine, we should expect a new wave of missile and drone strikes on power energy infrastructure. This will be a long test for the modern digital society based on information technologies and electronic communications. At this slide, figure shows a generalized individual-centric digital chain that connects a digital subscriber with a set of digital needs using a set of digital tools. As we can see, the key element of digital resilience is the tools of electronic communications, DT set. The initial element of digital resilience is the digital subscriber, DS, consumer of digital services. This is either an individual or a legal entity, and their needs vary, and their ability of tools for them is also slightly different. The risks associated with the lack of electricity power affect all elements without exception, but not to the same extent. Let's review what lessons Ukraine learned during last winter. We studied many use cases and user experience of interruptible power supplies, beginning with relatively cheap consumer models and also DIY systems based on car starter batteries, special devices to power up home routers and switches, and different battery types. Also, we collected use cases about attempts to use private power generation, solar and gasoline stations. We found and systematized many pros and contrasts for each technology. Then we reviewed the use cases of different internet access providers, their network technologies, and found significant difference to their resilience to power outages in a communication system level. We can return to these collections in a section of question sections. And so let's generalize given examples. According to proposal classification, the chain from a digital subscriber to a digital need at the very initial stage contains a large number of options for ensuring the digital resilience of the subscribers and their tools. Each digital tool can be analyzed and compared with others that provide a similar result. But to generalize the result, the most promising is the development of metrics that characterize the most effective resilience tools based on their availability, cost, time of implementation, reliability, and other properties. This metric approach approved by many researchers and can be combined with risk management theory. Such risk-aware metrics can be also introduced to evaluate digital resilience. For this purpose, we offer to review each property of a digital tool as a component of risk, either a factor of cost or factor of likelihood. For example, let's define some of properties of digital tools. Cost. How much does it cost to get this digital tool and use it? Accessibility. Implementation agility. How easy is to access this tool or switch to this tool. Reliability. A measure of the ability to perform the required functions in the given modes and conditions. And power autonomy. How much independent this tool is from power outages in comparison to other functional equivalent digital tools. Then, it's possible to evaluate digital resilience for an average household digital tools, which include redundant power supplies, diversified internet access providers, personal awareness, how to alternate power source for internet access equipment, and so on. And similar considerations can be made when analyzing network providers and data centers and each element of the entire chain between the consumer and the service. And that's the conclusion. Representation of individual components of the digital world in the form of topological space opens the way to learn the problem of digital resilience through the research of group properties, characteristics, dynamics of a large number of network structures. In the future, the study will provide an analysis of means and measures to ensure the resilience of digital services providers during the crisis of the electric power industry. I mean online stores, public information services, large data centers which host these services. In addition, it is necessary to develop metrics that characterize the effectiveness of resilience tools based on their availability, cost, implementation agility, reliability, and other criteria. Thank you for attention.